Hello, friends, and welcome back to Technology Now, a weekly show from Hewlett-Packard Enterprise where we take what's happening in the world and explore how it's changing the way organizations are using technology. We're your hosts, Aubrey Lovell
and Michael Bird. In this episode, we are looking at the challenges that come with introducing modern technology and sustainable engineering to reconceive one of the oldest, most rugged and popular car designs of all time. It's a reimagining of a classic 4x4 updated for the 21st century and is using HPE GreenLake technology to bring it into the future. So, how can technology develop a model that's been around since the 1940s and make it environmentally friendly? What role is AI playing in the future of car manufacturing? And how do you launch a brand new car in an already very populated market?
If you're the kind of person who needs to know why what's going on in the world matters to your organization, this podcast is for you. And if you haven't yet, subscribe to your podcast app of choice so you don't miss out. All right, let's buckle up.
Amen. Let's go.
So, four-wheel drive technology has been around since the 1890s. First in 1893, when it was pioneered for use in steam tractors, which we've linked in the show notes because, let's face it, it's a pretty cool looking patent. And then just 6 years later, in 1899, when one Ferdinand Porsche unveiled an electric hybrid 4x4 with a motor on each wheel powered by a petrol engine, which could also run for 40 miles on battery alone.
Aubrey, I wouldn't have put the plug-in hybrid as being invented in 1899. Oh my goodness.
Absolutely not, but there we go. And since then, the concept of the 4x4 has continued to develop and has arguably revolutionized the world, allowing access to remote areas, people, unmapped mountains, and rainforests, and more mundanely, the ability to get up really steep hills for engineering and agriculture.
Of course, 4x4 production in 2024 is very different from 80 years ago, or even what was cutting edge a decade ago. Safety, economy, emissions, gadgetry, it's very much all changing. And there are more challenges to come for car manufacturers in the next decade, with the UK government's announcement that all new vehicles will need to produce zero emissions by 2035, and similar lofty goals in many other parts of the world. But it's not just the car itself that's changing. IT is involved in every step of the process chain, from design to manufacture. And whilst advancements in technology have sped up the process, that also comes with its own challenges. The methods to train and monitor robots, as well as humans, are constantly evolving as AI plays a bigger and bigger part in car manufacturing. And where precision and accuracy have reached new levels with the use of computers, what are the potential pitfalls should the systems ever go down? To talk about all this and more, I caught up with Peter Grendel at a recent conference. He's the founder and managing director of a company which is responsible for the software being used to manufacture and support a brand new 4x4 fit for the 21st century.
My name is Peter Grendel. I'm the CEO and co-founder of ABAT Plus GmbH, GmbH, a German legal form. We are running a small software company and we are a partner of HPE.
Can you explain this wonderful car that we have behind us? What's the story behind it? And what's your story with the car?
Yeah, it's a wonderful car. It's a brand new car, so it's a new brand, never been on the planet before. And we are not a car maker, so we are a software company. And we are helping this car manufacturer to build this car from an IT perspective.
So what makes this car special?
Many things what makes it special. So first, the story behind the car. Because the founder of this company is a chemistry company, end of the day, and they had some ideas because they are car enthusiasts, and they like to have their own car. For this, he bought a company, so a plant, and now he's developing and producing his own car.
And so where do you fit into it?
So we came into this game when they had taken the decision to buy this plant, to design this car. At some point of time, it comes that you need IT to build something. And they was asking for an advice, who can be a good partner for preparing this and for doing this IT. The advice is ABAT and HPE. So then we came into this game.
Amazing. And so talk us through the challenges of designing a car and where you guys have come into this and brought your expertise. And I guess HPE have come in and brought their expertise.
Yeah. Designing of the car, I heard some funny stories how they designed the car. Actually, it was designed on a napkin. And a napkin in a pub in London. I hope this is true. I heard this rumor.
There's a lot of things designed in the UK that were designed in a pub on the back of a napkin. So talk me through the software challenges of designing a car and what you guys have done to help with that.
Yeah, normally when you buy a car, you go to a dealer and then you order a car.
Yeah.
Yeah, end of the day, this is maybe a piece of paper or it's a software system where you put your order in. Yeah, normally then you do a calculation. First question what you will ask, yeah, what does it cost and when can I get my car?
Yeah.
Yeah, and then the logistics starts to calculate when can we get all the materials in. And then the job starts with to build the car.
Yeah.
First you have a body shop. It needs welding, gluing, yeah, all these kinds of things to prepare the body. Then you have to paint the body. And then you have the assembly part to build the complete car, to put the seats in, to put the roof on, to put the windows in, and all this kind of stuff. And this is a complete process chain, what we call build to order. And the complete process chain is covered by our software and with our GreenLake approach. And what is also very important, this is a very critical environment. So when the system is down by whatever, a couple of seconds, so the line is stopped. And that is the reason why we are partnering with HPE, because this is a high available environment. Yeah, so the system has to be up and running at any point of time.
So where does HPE fit into this whole thing? What are HPE providing?
Yeah, so we use HPE as our partner, or we are a partner of HPE for the complete, what's necessary for the environment. So it is storage, it's computers, it's network. Yeah, and in the GreenLake framework, we have support services, we have implementation services, everything what is necessary to keep the system up and running. So it's a complete package.
That's absolutely fascinating, Michael. Thanks so much. And we'll be back with Peter Grendel in a moment. So as usual, don't go anywhere. All right, it's time for Today I Learned, the part of the show where we take a look at something happening in the world we think you should know about. What do we have, Michael?
Yes, and we're at the halfway point of the show, so I thought it'd be the ideal time to have a quick snack. You gonna have a snack as well, maybe? Just
sure. What are we snacking on?
Well, what about the world's first cultivated meat Scotch egg? Anyone?
Ooh.
No? Shame. Aubrey, do you know what a Scotch egg is?
I actually do, yes.
Oh, okay. Well, let me explain to some of the listeners who might not know. I would call it peak British cuisine. It's a boiled egg wrapped in sausage meat and then breadcrumbed and fried or baked. It's delicious. Good little picnic food, I would say. And now it's lab grown. So the retailer that invented the Scotch egg all the way back in 1738 has had the original recipe recreated using cultivated meat. So just in case you're not into your reformed lab-created cuisine, cultivated meat is produced when cells are taken from an animal and put in a bioreactor to replicate the meat cuts we know, usually with the addition of plant extracts to help give it a familiar look. Mouth-watering, maybe? Well, anyway, this version of the classic Scotch egg was created by taking a cell from an existing animal and fermented it in a tank, allowing it to replicate and form meat before being harvested and served up. The creators say that this type of meat causes 92% less emissions, uses 90% less land, and 66% less water. Unfortunately, though, you won't be able to try it anytime soon. And there's no word yet on where the egg came from, so I suspect traditional sources.
Interesting. I think I will skip lunch.
Right, now it's time to get back to our conversation with Peter Grendel about the technology behind a revolutionary 4x4 that's on our roads as we speak.
How is this car manufacturing process different to how other cars are produced? And what's your competitive edge in that space?
Yeah, there are some of differentiators. First is that we support the complete process chain from the early beginning, what we have spoken about, early beginning, down to the final okay when we hand over the car to sales. Based on this complete process chain, we have a data-centric architecture underlying. So we collect all relevant data from the production process. If these are welding dots, or if these are screwdrivers, or if this is gluing, or whatever is interacting with the vehicle, everything is stored in one database. Yeah, and based on this database, we can do in the future many interesting things with AI technology, for example, doing analytics. So this is one of the big differentiators what we have. And the other one is that we have the really high availability environment. And since we are doing this, the system was never down. So these are two very, very important differentiators. And in addition to this, we have what we have discussed with the GreenLake manufacturing environment, a full package. Yeah, so the customer is buying services from us. Even the availability, even the support, even the pricing is based on services.
Wow. I mean, it's quite interesting because you think, if one thinks of car manufacturing, they don't necessarily think that it's a high-tech environment. Most people would think, screwdrivers and paintbrushes or spray paints. So how important is IT technology to producing a car like this?
When you go to the body shop, when we prepare the body, you see only robots. Yeah, so only robots to do the welding, to do the screwing. Everything is automatically driven. So what we call the smart factory. This makes the quality higher as we have, the dot is exactly there where the dot has to be. And the screw comes into this hole where the screw has to go.
Yeah.
And we're telling with the system, the screw has this kind of torque. Therefore, we need IT.
I mean, if you've got robots, technology is important.
Yeah, the robots are not intelligent from themselves. So we have to tell the robots what they have to do. Yeah, and we have to ask them, have you done this? Yes, no. And they will give us the answer. Yeah, so we have to educate the robots and we have to guide the robots and tell them what to do, what they should not do. In the last, and I'm doing this since 20 years, and there were so many changes in the last 20 years. So first the robots came in, then software navigation came in, and we are working on some interesting technologies for the future, AI and quality, for example, to predict the quality. Not only to control the quality, to predict what kind of failures will come before you even know it. So this is a technology we are working on. Or some more guidance for the workers with smart devices. We are working that the workers have smart watches, that they are getting alerts, that they are getting what I call an attention assist, that we are working with the workers on technologies. When you're in a shift, outside temperature is 35 degrees Celsius, something like this. Your soccer team has lost in the weekend, or you have the early shift in the morning on Monday, that you have the awareness what kind of failures can come when I'm not in a good mode. Things like this will come. So automation and more flexibility with different models, that big companies will have different models on one line. So not only a gas car and a hydrogen engine, battery car, things like this will come, more flexibility and even more quality.
Thank you so much for your time. What an amazing looking car. What an incredible story. It's been an absolute pleasure speaking to you. Thank you so much.
Thanks so much, Peter, for talking to us. It's been great to hear about what's been going on with the car behind the scenes. And you can find more on the topics discussed in today's episode in the show notes. Okay, we're getting towards the end of the show, which means it's time for This Week in History, a look at monumental events in the world of business and technology, which has changed our lives.
Okay, so the clue last week was it's 1977 and things are about to get super. Aubrey, did you guess what it was?
No, but I really hope it's like disco related.
Oh, well, you are going to love this one because it is the anniversary of the shipping of the very first ever Cray supercomputer.
Oh, we love
this
Cray.
Week, a staggering 47 years ago.
Wow.
So the Cray 1 was shipped to the Los Alamos National Laboratory in New Mexico at a cost of $19 million for use in weapons testing. The system was a bit of a monster, a cylinder 7 feet tall and 9 feet wide. That's 2.2 by 2.7 meters. It weighed 5.5 tons and used so much electricity it needed its own substation. In fact, the monthly electricity bill of the system was $35,000, which is about $177,000 today. For that, you got a 64-bit processor running at 80 megahertz, 8 megabytes of memory, and 303 megabytes of storage space, all of which gave it a compute rate of 160 megaflops. Now, for reference, your smartphone probably runs around 2 teraflops. A teraflop is a million megaflops. So for those who don't want to do the maths, that's about 12,500 times more powerful. My goodness, we have come a long way.
We really have. Can we just stop and think about that for a second? I mean, number one, the amount of effort it would take to move something like that in 1977. But now we have that same technology, even more powerful in our cell phones and our tablets. Like, it just blows your mind, right?
Yeah. And I mean, it's just in my pocket and you can just carry it around.
Yeah. And it doesn't weigh 5.5 tons.
It doesn't weigh 5.5 tons. That's very true. Right. What do we have next week, Aubrey?
Well, next week, we're going a long way back because the clue is it's 105 AD. So
That is a long way
paper.
back. That is a long way back.
That's quite extensive. So take some paper and write that down. And that brings us mysteriously to the end of Technology Now for this week. Thank you to our guest, Peter Grendel, and thank you all for listening.
Technology Now is hosted by Aubrey Lovell and myself, Michael Bird, and this episode was produced by Sam Datapolan and Al Booth, with production support from Harry Morton, Zoe Anderson, Alicia Kempson, Alison Paisley, Alyssa Mitri, Camilla Patel, Alex Podmore, and Chloe Sewell.
And as always, thank you to our social editorial team, Rebecca Wissinger, Judy Ann Goldman, Katie Guarino, and our social media designers are Alejandra Garcia, Carlos Alberto Suarez, and Ambar Maldonado.
Technology Now is a Lower Street production for Hewlett-Packard Enterprise. And of course, we will see you same time next week. Cheers!